RL circuit, a circuit that contains a pure resistance R ohms connected in a series with a coil having a pure inductance of L Henry is known as RL series circuit. When an AC supply voltage is applied, the current I flows in the circuit. Any circuit including a resistor, an inductance, and an AMF that are in series or parallel is called an RL circuit. So IR and IL will be the current flowing in the resistor and inductor respectively, but the amount of current flowing through both the elements will be the same as they are connected in series with each other, where VR voltage across the resistor R and VL voltage across the inductor L and V total voltage of circuit. That is the illustration of Poisson diagram of RL series circuit. Steps to draw the Poisson diagram of RL series circuit. First, current I is taken as reference. Next, the voltage drop across the resistance VR equals IR is drawn in piece with the current I. Next, the voltage drop across the inductive reactance VL equals IXL is drawn ahead of the current I. The last step is the vector sum of the two voltages drops VR and VL is equal to applied voltage. This is the waveform and power curve of the RL series circuit. The various points on the power curve are obtained by the product of voltage and current. If you analyze the curve carefully, it is seen that the power is negative between angle 0 and between 180 degrees, and during the rest of the recycle of the power is positive. The current lags the voltage and thus they are not in phase with each other. To solve RL circuit's problem, you should apply the Kirchhoff's voltage rule to find the necessary equations. So, Kirchhoff voltage law or second law states that any complete loop within a circuit, the sum of all voltages across components which supply electrical energy such as cells or generators must equal the sum of all voltages across the other components in the same loop. An inductor with self-inductant L is used in a single loop circuit to stop the current from reaching its maximum value instantaneously. In RL circuit formulas, there are two cases. First, the case 1, as you can see in the illustration, in the upper part is the formula for case 1, where electromotive force of the battery in volts. L is the self-inductance of the inductor in henries. R is the resistance of the resistor in ohms. E is the base of natural logarithm. E is equal to 2.71828. T, which called the time constant, has units of the time in second and is the time it takes the current in the circuits to reach 63.2% of its maximum final value, I max. It defines as T equals L over R. In case 1, if we have a single loop in circuit in which components R and L are connected to battery with electromotive force, then the current in this RL circuit is obtained by formula. Next formula is the case 2, as you can see in the illustration in the upper part portion, where I0 is the initial current before the switch is closed. In case 2, If the source of energy battery is removed from the circuit by opening a switch, then the current does not drop to zero through the resistor instantaneously and takes some time. In this case, the current at any time is obtained. So, as you can see, this is an example of RL circuit problem. So, here is the situation. A solenoid with inductance of 25 mH is a resistance of 8 ohms are connected to terminals of a 6V or 6 voltage battery in series. There is also a switch in the circuit. You must find A. Immediately after the switch is closed, find the potential drop across the resistor. B. Find the final current in the circuit. C. Find the time constant of the circuit. And letter D. Find the current after one of the constant has elapsed. So, as a solution, recall the current formula in RL circuit at any instant of time is obtained by formula. So as you can see, this is the formula that being used. A, the problem A, the potential drop across the resistor in RL circuit is given by V is IR. So by setting T is equal to 0 in the above equation for current, we can find the current just after closing the switch in below. So this is how to solve the problem 1, the problem A. So next, it is how to solve the letter B. In RL circuit, the final or maximum current is found by formula IF is equal to electromotive force over R. The final current in this single loop circuit is, this is how to solve, is equal to 0.75 A. So next is letter C. By definition, time constant in our RL circuit is the same that takes the current reaches 63.2% of its final value. Therefore, T is equal to L over R. So as you can see the problem, 25 times 10 over raised to the power of negative 3 divide 8 is equal to 3 ms. So next is letter D. The current after on time constant is equal to, in the formula of capital I, small letter t is equal to big letter T is calculated as below. So let's proceed to LC circuit. An LC circuit is also called a resonant circuit, tank circuit, or tune circuit. Is an electric circuit consisting of an inductor represented by the big letter L and the capacitor represented by the big letter C connected together. The circuit can act as an electrical resonator, an electrical analog of tuning fork, storing energy, oscillating at the circuit's resonant frequency. LC circuits are used either for generating signals at a particular frequency or picking out a signal at a particular frequency from a more complex signal. This function is called bandpass filter. Operation of LC circuit. As you can see that animated diagram showing the operation of tune circuit or LC circuit. The capacitor or the symbol C stores energy in its electric field. An inductor L stores energy in its magnetic field, the color green. The animation shows the circuit at progressive points and the oscillation. The oscillation are slowed down. In actual tune circuit, the charge may oscillate back and forth thousands to billion of times per second. So an LC circuit oscillating at its natural resonant frequency can store electrical energy. So the animation, a capacitor stores energy in the electric field between its plates depending on the voltage across its. An inductor stores energy in its magnetic field depending on the current through it. So that's all. Thank you.